Before we get started, today we're going to be talking about performance testing for developers, and specifically getting started with performance testing. We're going to be going through a role play Q&A type of format during the webinar. I want to specifically call out if anybody has questions during the webinar, please send them in if they make sense. We'll fit them in while we're talking, and if not, we'll save them for the open Q&A at the end of the webinar. We'll be covering some high-level concepts and also be jumping over to show you things in K6 and load impact where appropriate. And again, just if you have any questions, send them over. So a little introduction. My name is Mark Meyer. I've been with Load Impact since the summer of 2015. I'm the team lead of the client success team here at Load Impact. And my primary goal is helping our users get the most out of our platform and really just get proficient with load testing and load impact. Outside of work, just a little bit about myself. I run, I hike, I build little Python programs to do little things, and I brew my own beer. I'm joined today by Ragnar Lönn. He's a founder of Load Impact and has been performance testing for quite some time, and someone I consider to be an expert. Ragnar, I want to hand it over to you to tell us a little bit about yourself.
Yeah, thanks, Mark. I'm Ragnar. I founded Load Impact, and I've been working with both software and hardware since the 1800s. Feels like. I really love programming. Outside of work, I drink Mark's beer sometimes. It's really good. I have way too many hobbies to list. I'm doing a bit of welding right now. Let's end it with that.
Very cool. So to go over the agenda, first we're just going to set the stage. So we'll present a scenario of kind of what we're doing. I'm going to take the role of a developer asking questions of Ragnar, and we'll kind of define what my parameters are. We'll go through that Q&A, and like I said previously, if you have any questions, please send them in, and then we'll go through an open Q&A for any open questions or anything we want to dig into deeper. So yeah, that said, let's move on and set that stage. So let's define the context that we'll be answering these questions. And the reason we're doing that is a lot of our answers would simply be, it depends, and that's pretty boring, and that level of abstraction isn't very useful when talking about load testing. So let's define some parameters. So I'm a developer. I'm working on a mobile app. That mobile app, the backend is hosted on AWS, makes use of a standard set of REST APIs, has a Python backend. Our app is live and it's growing. I've already have some automated test suites running, and my goals here, I want to know how scalable my app is, how I can detect performance regressions in my code base, gain the knowledge of how my app performs at scale. And the reason I'm doing all this is my CTO or my head of development, they've asked me to look into load testing and kind of define a process and bring the company up to speed with starting load testing. That all said, let's start with the first question. So Ragnar, thanks for talking to me today. My first question, I'm going to ask you, where should I start?
Yeah, so load testing can be really complex if you try to simulate reality really accurately. So we usually tell people to start small, and the first thing you need to, or the thing you really want to know, of course, is what parts of your system are performance critical and affect the satisfaction of your users. But that's really advanced. It's really high level user satisfaction, hard to measure. So we say that people should just, when they start, they're experts on developing their own app. They probably know which parts of the app, which endpoints, if it's an API-driven app, as in this case, which endpoints are performance critical and affect the user's satisfaction when they're using the app. So I would say start by guesstimating or guessing which endpoints are critical for you, and then start writing some small, simple tests that hammer those particular endpoints. And that's a really good start. It gives you a lot of bang for the buck, lots of return on invested time. So yeah, that's something I should think everyone should start with, and then they can progress from there and iterate on that.
Okay, so the key here, I guess, is I want to identify the most important components, endpoints, or pages of my system, probably ones that are tied to user satisfaction, maybe revenue directly, or just usability. So maybe logins or submitting of information, depending on what actions users can take in my app. And just start small with those endpoints, and I guess expand my use cases once I get some initial data to cover more and more areas of the app. I think that makes a lot of sense.
Yeah, exactly. And you can start by looking at what kind of load levels you're seeing on your live system and what kind of response times you're seeing for those endpoints. And then you can set your targets, your performance targets somewhere around there. Maybe set the response time target slightly higher than what you're seeing on the live system, and your load level can be also slightly higher than on the live system. And then you run your tests in an automated fashion and see if you have like regressions and stuff.
Very cool. All right, why don't we move on to the next question? And what are some things you think I should consider when writing my first test script? And before you answer, or while you answer this, I am going to jump out to a sample script so we can talk about some things kind of while you answer.
Yeah, there's lots of things to think about, but some things, I mean, you need to be able to control the amount of traffic that you push through. And one thing to do that is to insert sleep statements in your test code. That is something that you always basically do when you're testing a website, because a website, on a website you go to a web page and then you load another web page and so on. And when you've loaded a web page, a human user will pause. They won't do anything. They will stay there consuming the content for a while. So you need to have sleep time in between page loads to simulate reality well. For an API test, it's not the same thing, but you can still use sleeps to control the request rate that you're pushing through. The load testing tool will allow you to configure how many concurrent users or concurrent threads that you're using to generate the traffic. And sometimes it can be useful to slow down the threads a little bit when they're executing. Another thing is thresholds. Of course, you need to figure out when your test is a pass and when it's a fail. And a way to do that is to set up thresholds that say that, okay, response times above 40 milliseconds for this endpoint is a fail, for instance, average response times. And then the third one was that you mentioned, the parameterization is something else that can be useful. If you have, for example, a login endpoint where a user logs in with a username and password, and you run your load test with, say, 100 or 1,000 concurrent virtual users, it's sometimes not so great if they all log in using the same user and the same password. It can both mean that your test traffic is completely unrealistic, but it can also cause locks and stuff for your database or whatnot that would not happen in a real live situation because the traffic is different. So you want to spread things out. You want to use many different users, and then parameterization is good. So you don't have to put all those usernames and passwords inside your little script file. Instead, you can just pull them in from an external file, maybe, that contains all those 1,000 usernames and passwords. Those are some things, but there are more things probably. But I'll let Mark show you the code also now, so you can see how it works with the K6.
Yeah, I'm going to take off my my developer hat and put on my my load impact hat here to explain some things.
Mark is a bit schizophrenic in this call.
Ragnar just went through. It was sleep, thresholds, and then parameterization. I guess starting in that same order. Here we can see we have a sleep time, sleep, and then math.random. So I'm just calculating a random sleep time between 5 and 10 seconds at the end of this script. So when our virtual users get to this point, they'll sleep between 5 and 10 seconds. You can certainly hard code it to a single number, 1, 2, 3 seconds. What this value should be will really depend on what you're testing. Like Ragnar said, if it's a web page, probably having a fair idea of how long it takes users to consume that page or fill out a form on that page, so it should mimic that. When testing API endpoints, it's probably going to be shorter, and you'll use it to just help with pacing to make sure the virtual users are stable in how they're making their requests. You don't want to let them overachieve and overutilize the load generator. Moving up to the second item, thresholds. We define them as a binary pass-fail metric for a test. So thresholds should evaluate to true. In this case, so we're looking at the HTTP request duration. If it's less than 500 milliseconds on the 95th percentile, that is true, then it passes. If it exceeds that, it would fail. Thresholds are very handy when integrating with CI tools, as they'll cause the test to exit with a non-zero exit code. Thus, it can fail that build or deployment or whatever step it may be. So you kind of know right away when there's a performance problem and that code isn't pushed any further. The final item is parameterization. Here we can see in my request, I have this post to a login, and I'm just pulling a username and password from. I did not take Ragnar's suggestion of using an external file. I just put some data right in my script. Probably fine if there's a small amount of data, but basically just pulling some information there. I've hard coded this to the first position, but you can do some different methods to randomize that or access it in a certain order if needed. Ragnar, anything you want to add there?
No, I don't think so.
We did have a question from Christian. Well, two questions. I'll get to his other one later on. But we talked about external file containing usernames and password. Will it work?
I was just responding to that one. Actually, yeah.
So let me repeat it again. You talk about an external file containing users and passwords. Will it work on both local and cloud testing? Yes, if you're using K6, if you're triggering K6 tests from the command line, when you use it locally, it'll just grab that file and access it. If you're using K6 Cloud to execute your test, that file will be uploaded as a dependency and executed on the cloud. And then another question, but I think we will get to that later.
Maybe we should save the questions.
Yeah, I think so. And
we might get bogged down, you know.
Yeah, we might get caught up. Yeah, we'll go through that.
But keep them coming.
All right, so moving on to my next question, putting my other hat back on. So how long should my tests run, Ragnar?
Yeah, so that's a good question. If you there's two basically different types of tests that you can run. The website test, where you're testing a user journey that can be quite complex, requires quite a lot of time to run. This wasn't the persona we were talking about in this call, so I won't get into that too much, but it generally takes much longer to run a website test when you have a complex user journey with multiple actions that the user performs. But if you run the simpler API endpoint tests that we've been talking about, then you don't need to run the load test usually for very long. You need to run it for long enough that you get stable test results. Because when you start a load test, the target system can be shocked because there's suddenly a huge influx of traffic, and like caches, and there's lots of allocations and connection setup and whatnot that happens, which means that initially the server can be quite overloaded almost, and response times can go through the roof briefly. But that's not something that usually happens in a real situation, because traffic usually doesn't rise that quickly. So when you run a load test, what you want to do is you want to start the load test, and maybe you can ramp it up really quickly if you want to, but then you need to wait until the results have stabilized, until the target system has adapted to the new traffic level that you're exposing it to. So in the case of API tests, often you can run a test for just 10-20 seconds and get good results. But initially, the first thing you do when you've coded a test case, when you've written a test script, is to run it manually and do exploratory baseline testing to figure out exactly where your performance are before you automate things and run it in your CI pipeline. So when you're doing that, when you're running it manually the first few times, then we would recommend that you run the tests for a few minutes, just to be sure that there are no surprises and that you get stable and good test results. And then you can shorten that time when you learn how your system performs and how long it takes for results to stabilize in your case.
Very cool. So I guess to recap that, as it relates to our scenario, my first test, I'll probably want to run them for a few minutes, and then for testing those API endpoints. And then as I learn about the system, I'll be scaling that back or shortening it, because I realize how long it takes me to get the result data set I need. I guess the key takeaway there is I need to run the test long enough to produce actionable results. And that's probably...
And stable results. You don't want false positives.
True. And I guess that's clearer when doing website or web app testing, where we're running tests that simulate user journeys or user scenarios, that we need all those virtual users to complete that scenario multiple times, so they can hit all those endpoints, and the system, all the things we're trying to test, can be requested properly.
Yeah.
Very cool. All right, let's move on. So this is a fun question, and one I see often. How do I interpret my results? And to kind of aid in our description here, Ragnar, I'll share my screen, and I have a test result for you to look at. And why don't you just bring us through what you would look at? All right, so Ragnar, how do I interpret my results? This is a test I've run.
Yeah, so looking at the graphs, we have three different graphs in this chart. We have views active, we have request rate, and we have response time. And the views active is the virtual users, the number of virtual users. That's the load level we're subjecting the target system to. And what you want is for the request rate to follow the load level, so in a linear fashion, and that's pretty much what we see here. So that's looks pretty good to me, because if there is a problem somewhere, if the target system can't respond fast enough, usually you get a lower number of requests per second throughput. The throughput goes down, and then you will see the request rate not being able to keep up with the number of views. Then we have the response time, of course. Another thing that can happen is that the response time suddenly gets worse, and that can also be that can be followed by a lower request rate. So basically, you want response time to remain stable, while request rate should follow the number of views, the amount of traffic you're trying to push through should determine how many requests you're actually pushing through. So I would say this result looks quite good. You have a ramp up first for like, I don't know, a minute or so. I think this test runs for, is it?
For 5 minutes.
5 minutes, 5 minutes. Yeah, well, you have a short ramp up in the beginning, and then you stay stable at like 200 virtual users, I think, for the majority of the time, and then you ramp down at the end before the test finishes. And the request rate follows the ramping quite well, and the response time looks pretty stable. You can see in the very end there, the response time suddenly drops a lot. And you can also see, not in this test maybe, but it's often spiky in the beginning. So it's important to not look at the very ends of the test, because that's where strange things tend to happen, but look at the stable parts in the middle.
Very cool. And I guess to also call out, if I can throw my load impact hat on, this test, the result looks good, but we did have a failed threshold. So for this test, or whatever I was running against, that's a signal, hey, something's not performing up to my standard. System could handle the traffic, but it couldn't hit whatever that standard is that I set. I think we'll take a question here because it's related. Are thresholds evaluated for each iteration at the end, and will a false result abort the test?
The thresholds are evaluated at the end. I think they're updated throughout the test, but the pass or fail is determined at the end of the test. And what was the other part of the question?
That was the question.
Okay.
Very cool. All right, so let me jump back over. I will present again. So I guess just to recap there, so what you're telling me is I'm looking for trends in my initial data, trying to understand, I guess, those 2 key points of response time and then the throughput metric of request rate, looking for those trends. So response time should be flat and stable through the test, and my request rate should follow the same trend as my virtual users throughout the test. I guess there could be exceptions if you did some weird scripting, but in general, that's what should be followed. All right, we move on then. So I know different test configurations can tell us different things. What are some different ones, and Ragnar, what can we learn from them?
Yeah, so I talked about the exploratory manual baseline tests that you should always start your testing with before you automate things. When you're scripting, when you write the test scripts, you run a manual baseline test to figure out exactly where your performance is at the moment, to be able to set reasonable thresholds. And the thresholds they're meant to like catch regressions when you run them in your CI pipeline and in an automated test suite. You have regular load tests, which means that you subject the target system to a fair amount of artificial traffic, and you see how it reacts. And you can either use a fixed amount of traffic, or you can have a ramp up test where you ramp up from a low traffic level to a higher traffic level. That's the general my general definition of a load test. A spike test is where you ramp up the load really, really quickly, and that's a kind of a special case. If you think you might have a sudden traffic spike, you may want to test for that just to see how your system can handle, how it handles that. For example, if you have if you're doing advertising on TV, for instance, you have an ad spot on TV, that can cause a huge spike because all people, lots of people will see it at the same time, and they might access your app or your site at almost the same time. Another type of test is a stress test. A stress test is where you're trying to make something almost break. You're trying to increase the traffic until something bad happens, basically. So you're trying to ruin the performance, ruin the response times, or make some part of the system stop working. And stress tests can be really good to understand where you have bottlenecks in your system and which parts of your system tend to break first. So when you do have a performance issue at some point, you'll know where to look. You'll know where the usual suspects are because you've done some stress testing and you know that these components don't scale well, or that component, it always fails at that traffic level. So we'll look at that first now that we have this issue here. Endurance tests is more like if you have a memory leak or something that only affects the performance of your system after a while, because you have to leak enough memory for the system to start running out of memory before it will affect performance. And then you might need to run a test that generates a fair amount of traffic, and you need to run it for quite a while before you'll see anything happening. So those are also useful tests to run, but one problem with endurance tests, of course, is that they take quite a while to run. So they might be something you run in an automated way, but it's probably better if you have a separate system to run them on, so you don't try to run other tests while the endurance test is running. Yeah, and I think I've covered it all. Have I?
Yeah. No, that's great information. I think the key thing to take away there is that testing is very comparative. So running different test types and kind of comparing results from one to another can give you different insights, especially when comparing to your baseline test and then seeing what happens under different traffic patterns and load patterns. All right, cool. We'll continue on. So aside from how many users my app can handle or my endpoints can handle here, what else can performance testing tell me?
Yeah, so trends that you just mentioned, that's very interesting. Trending is useful to catch regressions. So if you have a test that you run repeatedly, you can usually quite easily detect a regression. And even if your thresholds are not exceeded and you get fails, you can still see that the performance goes down over time. And that can be really useful because sometimes you have a code base where you're doing stuff that slowly decreases performance. One commit decreases performance just 1% or 2%, and then a bit later there's another commit that decreases performance a little bit more, and then it continues like that, and after a while you suddenly have an app that only performs half as well as it did a year ago, and you didn't see it happening because your traffic level on your live system never ran into scalability issues, so you didn't see it there. So, but if you're testing regularly, if you're doing performance tests regularly through your CI system, and you look at the trends, you can see if the performance goes up or down or stays level, and that's really useful. Another thing we've seen is that people sometimes run into completely unexpected bottlenecks or limits in their system. We had one customer who had they suddenly they had an influx of traffic for whatever reason, and the system just couldn't handle it, or the system got really slow, I think. And they couldn't understand why, because everything seemed to be idling, so the infrastructure seemed to be fine. And in the end, it turned out to be a license for a firewall that was the issue. So they had to upgrade the license for the firewall. The firewall was fine. I mean, it wasn't using any CPU at all almost, but the license just started throwing away IP packets when they exceeded a certain traffic level. They had to pay their firewall vendor more money, and they didn't know that. So that's something that they could have detected if they'd run performance tests above their normal traffic level. So, and then of course today, or always, I guess, people pay for infrastructure. They pay for the infrastructure, and if you run regular performance tests, you'll be able to optimize your app and reduce the amount of money you pay for your infrastructure, and that's also a win in the long run.
Yeah, I think if you could go back to your head of development, CTO or CFO and say, hey, I ran these tests and it's going to save us money because we don't need to spin up as large of instances, or I've found a performance improvement, they'll probably appreciate that.
Yeah. So if you run performance tests and you see where your weak points are in your app, then sometimes it's really easy to fix a couple of those, the obvious ones, the low-hanging fruit, and improve performance quite a lot. And then you save money on infrastructure because you can downgrade the size of the AWS instances you use or whatever.
Very cool. Yeah, so it sounds like well, performance testing can tell us more than just how many users we can handle. So a lot of good things we can take away from it when running tests on a regular basis. So why don't we move on? And here's a fun question. So I've already run some tests, and we've walked through this. How often should I continue running my tests? I mean, am I done right away? Well, kind of what's next?
Yeah, so there's the really simple endpoint hammering tests we've been talking about that can be run pretty quickly. That's on one end of the scale, and then on the other end of the scale you have these complex user journey website tests that can take a long time to run. And I think the complexity of the test and the runtime of the test determines how often you should run them. There are probably other aspects also, but in general the runtime affects how often you want to run a load test. So if you have a test suite with small API endpoint tests, each test might just take 10 seconds to run. But if you combine them all, and there are quite a lot of them, then it will still take a while to run. And it might mean that you don't want to run them on each commit, but in a nightly build probably would be fine. So in general, we think that for those types of tests, when you have simple API endpoint tests and a bunch of them, then running them once per day, nightly, is a very, very good frequency. Of course, there are exceptions, but for maybe 90% of organizations, that's a good frequency, we think.
Cool. So yeah, I guess to recap that, it sounds like nightly builds are the most common frequency, but I suppose every organization is going to have reasons that they might want to increase their frequency or lower it. And I probably want to run my unit test type of testing more often than full-on user scenario type of testing.
Yeah. I mean, if we look at the persona we were talking about now, they wanted to get started and they wanted to run small API tests, API endpoint tests, and they should probably run them nightly. But once they proceed and start making, taking these endpoint tests and maybe combining them into more like integration type tests and maybe almost user journey style tests, they will probably realize that some of the tests they should run less frequently, the bigger ones, the more complex ones that take longer. So maybe they want to run them only occasionally, and they run all the small tests nightly. So it's it varies how exactly how what your setup looks like, but there will probably be several different complexity levels once people have become advanced load testers.
Very cool. All right, we move on then. So as I mentioned at the beginning, my head of engineering gave me this task of developing the process for load testing, and I want to make sure that this initial work I put in doesn't need to be duplicated across the other people that are going to be involved in load testing. So how can I ensure that this initial work and time I'm putting in is scalable to the rest of my team and company?
Yeah, so I think it's as if we have mostly software developers on this call, I think they know how to do it. You need to develop software when you're writing your tests, your load tests. It's just like writing unit tests. You want to make sure you're using version control, and you want to make sure you reuse parts of the code that are reusable. Many organizations have people who are writing like almost test frameworks for internal use that other people then use when they write their test cases. And I think that's probably a good way of doing it. You need to import stuff that standardize and import things. Of course, collaboration is good when you can look at each other's test results and share everything. We have in Load Impact, the online service, we make it easy to share K6 tests and results. And it's possible, of course, with other solutions also. But in general, develop your tests like you develop software or like you write functional test suites. Version control, modularization, and there's probably other things to think about also, but software development best practices.
Yeah, so I guess to recap that, use the version control system I'm probably already using in my day-to-day development. Take advantage of that modularization available in K6. So I guess I can use that to standardize some things to share with my team, and then results are being sent into the Load Impact Cloud. I can invite others to access that either through a share link or inviting them to my organization and Load Impact directly.
Yeah.
All right, cool. I think it should be the last question. So before we move to the open Q&A, first, thanks Ragnar for giving us all that information, letting us download it from your brain. But for everyone else on the call, again, right before we move to the Q&A, here's some helpful links and important links that we think everyone should have. Won't go through it line by line and read it to you. You can read that yourself. And of course, we'll share these links